Hey there! Have you ever wondered how electricity actually works? We use it every day charging our phones, turning on the lights, and watching TV, but do you really know what's happening behind the scenes? Well, today we're going to break it all down in a super simple way. We'll talk about where electricity comes from, what makes it flow, and how batteries generate power. And don't worry, I'll make sure it's easy to understand, even if you've never studied this before. Let's jump right in. Chapter 1. When electrons move, electricity is created. Electricity happens when electrons start moving. If electrons stay in one place, there's no electricity. But the moment they start flowing, that's when we get power. There are two types of electricity. The first is static electricity. This happens when electrons build up in one place and suddenly move. Have you ever taken off a sweater and felt a little shock? That's static electricity at work. The second type is current electricity. This is the type of electricity that powers our homes and devices. It happens when electrons move in a continuous flow through a conductor, like a wire. Imagine rolling marbles down a tube. If they're sitting still, nothing happens. But if you give them a push, they start rolling just like electrons in a wire when electricity is flowing. Chapter 2. Everything starts with atoms. To understand electricity, let's start with atoms. Everything around us, air, water, even your own body is made up of tiny building blocks called atoms. You can think of atoms like tiny Lego bricks that make up everything in the universe. Inside every atom, there's a center called the nucleus, which contains protons that have a positive charge and neutrons, which have no charge at all. Surrounding the nucleus are electrons, which are much smaller and carry a negative charge. People often say an atom is like a tiny solar system, with electrons orbiting the nucleus like planets around the sun. That's a useful way to imagine it, but in reality, electrons don't follow fixed paths. Instead, they move unpredictably in what scientists call an electron cloud. But the important thing to remember is that these electrons can move, and when they do, they create electricity. Chapter 3. What is charge? Now let's talk about charge. Since all atoms have electrons and protons, everything around us has some kind of charge, but not everything can conduct electricity. Here's a simple way to understand it. If an atom has the same number of protons and electrons, it's neutral, there's no overall charge. But if an atom loses electrons, it becomes positively charged. And if it gains electrons, it becomes negatively charged. A great example of this is table salt NaCl. When salt dissolves in water, it splits into sodium ions, Na, and chloride ions, Cl. These charged particles help water conduct electricity. That's why salt water carries electricity well, while pure water doesn't. Pure water doesn't have enough charged particles or electrolytes to let the current flow. So, charge is important because it allows electricity to exist and move. Chapter 4. Conductors and insulators. To keep electrons moving, we need materials that let them flow easily. These are called conductors, and metals like copper, aluminum, and gold are great at this. That's why electrical wires are made of metal. On the other hand, some materials block the flow of electricity. These are called insulators, and they include plastic, rubber, and glass. For example, power cords have a plastic coating around the metal wire inside. The plastic doesn't conduct electricity, so it keeps the electricity flowing where it should inside the wire and keeps us safe from getting shocked. Chapter 5. Does slower electron speed mean less current? You might think that if electrons move more slowly, there's less electricity. But that's not necessarily true. Electrons inside a wire actually move really slowly, way slower than you might expect. But here's the thing, wires contain millions of electrons, packed tightly together. So even if each electron moves slowly, there are so many of them that they still create a strong current. Think about a highway. If the road is narrow, fewer cars can pass. But if the road is wide, even if the cars are moving slowly, a lot more can get through at once. Electricity works the same way. The more electrons that can move together, the stronger the current. So when current drops, it's usually because voltage decreased or resistance increased, not just because electrons slowed down. Chapter 6. How do batteries generate electricity? Now, let's talk about batteries because they're basically tiny electricity factories. Inside a battery, a chemical reaction builds up electrons at one end. But electrons don't like to be crowded together. They naturally want to spread out. The only way for them to do that is by traveling through a circuit. Here's what happens step by step. Inside the battery, a chemical reaction pushes electrons to the negative terminal cathode. But electrons can't just inside the battery, they need a path. When you connect a wire, electrons flow through it, creating an electric current. At the positive terminal anode, electrons are accepted, completing the circuit. Think of a battery like a water pump. Just like a pump pushes water from one place to another, a battery pushes electrons, creating a steady flow. And the force that makes electrons move, that's voltage. Voltage is just the difference in energy levels between the two ends of a battery, just like how water naturally flows from a higher place to a lower place. Conclusion: why understanding electricity matters. So today we learned how electricity works, from atoms and charges to moving electrons and batteries. Here's what we covered. Electricity happens when electrons move. Static electricity is built-up charge, while current electricity is moving charge. Metals are good conductors because they let electrons flow freely, while plastic and rubber block electricity. The speed of electrons doesn't always affect the strength of electricity. It's also about how many electrons are moving at the same time. Batteries use chemical reactions to push electrons and create electric current. Now that you know the basics, you'll start seeing electricity in a whole new way. If you found this video helpful, don't forget to like, subscribe, and turn on notifications. See you in the next video.